Welcome to the physics videos on static electricity by Shivam Kumar. First of all, we are going to discuss about electric charges. So these electric charges are the intrinsic property of certain fundamental particles like electrons and protons. We know that electrons and protons are present inside the atom. So these electric charges have capability to produce magnetic as well as electric field. There are two types of charges, positive and negative charges. Now we are going to discuss about how to charge a body. We have studied about charges. Now how to charge a body, a neutral body. So there are many methods of charging a body, but here we are going to discuss about three major methods. So first one is charging by friction. The second one is charging by conduction. And the third one is charging by induction. Now, first we are going to discuss in brief about the charging by friction. So in charging by friction, we take two bodies and they are rubbed against each other. They are rubbed means the rubbing takes place against their relative motion. So in the two bodies, among the two bodies, one body, at least one body must be non-conductor. You know that non-conductor is that substance that does not allow heat or electricity to pass through it. So when the rubbing takes place between the two bodies, heat is generated, and this heat is responsible for making the electrons excited. So the body with more electron affinity attracts some electrons from the other body. So what is this electron affinity? See, electron affinity is the energy required to provide one electron to we can say to insert an electron inside a neutral atom. So when we provide an electron to a neutral atom, then it becomes negatively charged. We know that obviously it becomes negatively charged. Okay, so when these both bodies are rubbed each other, they develop equal but opposite charge. Like if one body develops +1, +1 charge, then obviously the other one will develop -1 charge, means -1 charge. Means the magnitude of charge will be equal, but the sign of the charge will be different, means opposite. Now the charging by conduction and induction. So first of all, we are discussing about conduction. So conduction in this process, an uncharged body is taken first of all, and in that uncharged body, a charged body is made in contact to it, and this contact relationship with the both bodies results in transfer of charges from the charged body to the uncharged body. But remember a point, that this conduction takes place only when they are in contact. Now induction. See, induction is a similar process like conduction, but the difference is that the charged body is not brought in contact with the uncharged body. It's just made near to the uncharged body. Means there is some distance, there is small distance between the charged body and the uncharged body. Okay. Now the properties of electric charges. What are the properties of electric charges? So first one is that like charges repel each other and unlike charges attract each other. Like if we take positive and positive charged body, means two bodies of both positive charge, then obviously they repel each other. And if we take a body of positive charge and another of negative charge, then they attract each other. Okay, now the second point, that charge is a scalar quantity. Means it has magnitude but has no direction. Now the third point, charge is conserved. What does that mean? This means that when two objects, by rubbing, when two objects are charged, one body gets positively charged and one gets negatively charged. We have studied before. So their magnitude of charge is same, but the sign is opposite. Now let's take that the first body acquires positive 1 charge, plus 1 charge, and the another one, obviously it will acquire minus 1 charge. So the resultant charge after their interaction, after the rubbing, becomes 0, and this interaction that resulted in 0 is equal to the charge that was before the interaction. That means neutral charge. We have taken two neutral body for rubbing, so they had charge 0, and now after the interaction also the resultant charge has come 0. So this means that the charge is conserved, means the charge is neither created nor be destroyed. Now the last point says that total charge remains conserved. That only we have learned in the third point. Means the charge can neither be created nor be destroyed. Now the units of charge. The SI unit of charge is Coulomb, that is given on the name of the scientist, Coulomb. So 1 Coulomb charge is equal to the charge of 6.25 into 10 to the power 18 electrons. Just imagine it. 6.25 into 10 to the power 18 electron. The charge of this much electron will be equal to just 1 Coulomb of charge. Now we are going to study the Coulombs law. What Coulomb had given, what he has introduced. So this Coulombs law was given by Charles Augustin de Coulomb, and this law acts along a straight line joining two charges. Remember this point, this is important. This Coulombs law says that F equals to Q by R square. This is the formula of Coulombs law. So the force is repulsive when the charges are like, and the force is attractive when the charges are unlike. This we can find from seeing the magnitude of charges and the sign of charges when we solve the questions. And the last point says that the force is directed along the lines joining the center of the charges, center of the both charges. This point is important. So thank you once again.